In code blocks, let's create a project, BinaryTree. We add a file. What should be the file name? What is the first file we should add? Header file. So let's give it a name. BT node. A short name. Select all. Finish. Second file, new file. Yeah. So one header and one C file. Now, how do we define structure? Type def BT node, because we are defining node, it's not a tree. Now we define our structure. Small. Yeah. Abhinay, what should be the value in this?
BT node
Struct we are defining.
BT node star
BT node star root. We are actually creating a node structure. One node of the binary tree, what should be there in that? So in one node, how many members will be there?
3 right.
Left, right, not root. We want to store some value. So let's take left, right, int value. Sometimes if you want to store a pointer to parent also, we can define another BT node star parent, but that is not used widely. It helps us solve some problems easily so that we can traverse back. It's just a variation, like we have doubly linked list to go back. Basic structure of tree will be this. So we have a value, each node will contain a value and 2 pointers. So that is what we have created. Because we did a type def earlier, we are able to use it. Now the first function we should define is create BT node. One node if you want to create, that is the function we are defining. Input parameters.
Value.
What is the value we want to put in that node? So what is the type of value? What should it return? BT? So what will be the goal of this function? What will this function do?
Initialize values.
It will allocate memory for one node and all 3 members will be initialized. Value will be initialized with this. What will left be initialized with? Null. Right? Null. So create BT node is first function that we want. Yeah.
Do we need to first create root, or isn't it required?
So now, if this is what you have defined, in main if you go, ideally you will say, here you are defining root.
Okay.
Now, whatever insertion you are doing, you will be doing it with this root. Initially root is null, tree is nothing. So now, using this root, we will be calling all the functions.
We are not doing like the previous linked list, what that we have wanted.
No,
We are hiding it.
No, right now we are not hiding. Like in linked list, we first define the node, then we use node from main directly, head we were defining. Right now we are going with that approach. So this will create a node. In main, if I want to insert first node, I can call create node function. Right now that is in the header, that is exposed. Next function, what do we want? In linked list, what is the first function we wrote after create? Insert. In tree also we need an insert. But where to insert will be a question. In linked list we know we can insert in beginning or insert in end.
It goes in the left node.
Yeah, so you should have a function like insert in the left, right? So insert left. So we are inserting left child of root. That is the function we are defining. So what does this function need? It needs data that we want to put and root. Root also needs to be specified in which tree are we inserting. So let's take root as first, data as second. Okay, let me define that also as data. Previously we used data only, right? So that we don't confuse. What will be the return type of insert left? Why? We are saying take root from me and insert as the left child. Root is given to you.
Okay, we don't need to return.
So we are giving one node and we are saying insert to the left of that node.
Void.
Then if we are inserting on the left of root, we should return void, right?
If it's already full, then
Will this function ever replace the root?
No.
No. So because we are never updating root, we don't need to return that, right? But if we are saying insert in a tree, if it was a binary search tree which has a probability of, or if it is a tree which has a probability of replacing even root, then we want, because root we want to update in main. In main we have root. But here because we are saying insert left of the node that I am giving, then we don't need to return anything.
Insert at end also we are not replacing it. No, sir.
Hmm?
In linked list, insert at end.
Insert at end we were not replacing, but if linked list is empty in the beginning and you are inserting in end, first element is replacing head. So that's the reason we returned. So in this case, we don't want to do anything. Second, insert right. That will also be the same. So in main, if we have to call insert left, insert right, first root we will create, because root insertion is not given as a function. So let me put 2 at root. 1 will be the left child, 2 will be the right child. So can I say insert left root 1, insert right root comma 3. So our root is intact, root is always pointing to 2. Now if I call one more function and say insert left root 5, what should it do?
5 to 3. It overwrites.
Go to 3.
From 2 we are inserting 5 as left child.
Right of 3.
Right of 3. Why? We are saying insert as a left child. 5 should become left child of root. So right now root is 2, left is 1, right is 3. Now 5 is coming as left child of root. So what should happen? 2 had a left child 1. 5 should come in between and 1 should become left child of 5. Can you say that? So let me draw it.
We are inserting to the immediate left of root.
Yeah. If this is 2, we had 1 here and we had 3 here. That is the original tree we had. Now we are saying create a node 5 which should be left of this. But this has already a left child. So what we will do, 2 we have, we are going to insert 5 here, but whatever was left child of 2, that becomes left child of 5 now. That means one shifts down. So 5 we are inserting as left child of 2 only. 3 is as it is. Clear? So that is how we will be defining. Now if we say, if we call this function again, insert right child of 2 and we give 4.
2, 4, 3.
2, 4, 3. That is what it should become. Right? So whatever is below that should become child of the node that we are inserting. So now if, let's say somehow we will define another function which will be search a node. Search will give us pointer to that node. So if we search for 5, we get address of 5. Now we call insert right with 5's address. So insert right of 5 if we do and say 6, that will help us make this tree. After that, if we say insert left, root we pass and we say insert left 4. 24516. That's how we'll be able to do this. So initial functions that we have talked about, we need insert left, insert right. Then if we want to insert somewhere at the bottom, we need to find that node address. That means we are going to define another function which is search function. So search. What should be the
value?
search? Should take root so that it starts searching from there. It needs return type BT node.
Star.
Abhinay, why it is BT node star? So what we are doing here, let's say if I want to insert a right child of 5. What we want to do? Insert right child of 5. So we have defined a function insert right, where the first address we want to give of 5. Do we have 5's address? Right now we don't have, because we know root only. So we want to call function search. Search will go in this tree, it will go to 5, it will find its address and return to us. So once we have that address, then we can make right child of that. Fine. So search is going to return the address of the node which contains given value. Because we want to get the address, that's why we're returning BT node star. So if we have this, then what else do we need? We need delete also. Given a value, given a data, go and delete that node. So what should be the delete signature? What should it take?
Root
and data. Take this root and search for a node that contains this data and then go and delete that. Here we can, return type will be
BT node star.
yeah. Now why should return type be BT node star?
It may update the root.
Yeah, because if there was only one element and which is root and we want to delete root, after calling delete, root should become null, right? Or if tree was full-fledged tree was there, root had 2 children and we are going to delete root, then right child should come forward and become the root, new root. So root will be updated. So delete node has chances that root may get updated. Not in all cases, but in some cases where root is deleted, it will be updated. In all other cases, it will return root directly. So what should be return type? And then in linked list we define a function traverse, which was going in printing all the nodes values. So here also we need a traverse. But in tree there are multiple traversals that are possible. In order, pre-order, post order. In order means print left first, then root, then right. So pre means print me first, which is root first, then left, then right. And post order is left, right, root. Post means I am in the end. So root is in the end. So these 3 traversals are possible. For now, let's define only one. In order. So all these traversals are very important for understanding trees. So we'll pay special attention to 3 traversal: in order, pre-order, post order. Both recursive. Recursive anyways we by heart, 3 lines. Right? But iterative also we'll do. In iterative traversals that we will do, we'll be using stacks. Yeah, Q will be using when level order traversal will come. There is 4th traversal, level order. So in order traversal, what should be the input parameter?
Root.
That's it. Return type?
Void.
Why?
It's just printing.
Yeah, because we want this function to print. Don't return anything to us, just print. So it does not return anything to us. So with this, btnode.h is defined. Now next step we have to do is we have to implement all these functions in this. But before that, we'll write some unit test here, so that when we fill our main, then we know when we run what is the output we are expecting. So first we talked about insert left 1, insert right 3. Now insert left 5. Now it becomes 2, 5, 1, 3. Then we call search. We pass root and then we pass 5. We are finding the address of 5. After we find the address, we will call insert left address of 5 and then we insert 4, address of 5 and we insert 9. After this we have defined in order. So this should print in order traversal. Apart from this, search we have used. So search we have used, only thing we have not used is delete. Another thing that we want to do is when we call search, search can return us null pointer if it does not find the value. So here we should have that if 5 equals null. The reason I am putting this is later on we will change this value to some other value and search that. Printf or because we want to test our search, why to have it here. Let's define it. That also becomes another test. Because 5 is defined already, we use it to search for value 10. And that should return null to us. Fair? So we have added that case also so that we can test for null. Then delete node, we pass root and we pass, let me delete a leaf right now so that 3 and then we say in order root. So after deleting also we will print the tree. So once we have implemented all these functions, our main should run perfectly fine. There should be no crashes and each line should give us desired output. So this is a basic project that we will start implementing. So let me upload it so that we all have same functions. So today is day 1 on binary trees. So there are some more functions that I just defined in this PPT. Create 3-node tree. Quickly, if we want a tree so that we can check our traversal, create 3-node tree where you give root data, left data and right data. That is, in this function we can call create node 3 times, and using existing functions we can make this function easily. So whatever we have defined till now are the base functions that will help us build any big trees. Create binary tree. If you give left subtree and right subtree and you give a root. So if you had 2 trees already with root, you bring a third node as root and you just left and right you make these subtrees. Insert left we have seen, insert right, this we have seen. Then we will go and define create random tree also. If we give a node count, then up to you, you create any tree and give it to us so that we can test our code. So today you have class, you want to leave and start tomorrow on implementation, or you tomorrow? And anyways, Kirti also hasn't come, so it will be good for us, for her.